For decades, scientists had a test. It was called the Mimas test. And the rule was simple. Any theory that explained why Enceladus has a hidden ocean beneath its surface had to also explain why Mimas, Saturn's other small moon, absolutely did not. Look at it. Heavily cratered, ancient, frozen solid for billions of years. No geysers, no heat signature, no activity whatsoever. Scientists looked at Mimas and saw a dead world, a rock that survived the violence of the early solar system and simply stopped. In fact, Mimas looked so dead, so obviously frozen all the way through, that it became the scientific benchmark for what an ocean moon is not. And then, in February 2024, researchers at the Paris Observatory ran the numbers on something they'd been quietly tracking for years: the tiniest, almost invisible wobble in the way Mimas orbits Saturn. And the math came back wrong. Not slightly wrong, not close enough to explain away. Wrong in exactly one specific way. That meant only one thing was possible. There is a global ocean of liquid water hiding 20 kilometers beneath the surface of Mimas. And nobody, not a single scientist on the planet, saw it coming. But before we go deeper into this story, if you're new here, welcome. This channel is dedicated to the most mind-bending discoveries in space and astronomy. Every week we take a real scientific finding and tell its full story, the way it deserves to be told. If that sounds like your kind of thing, hit subscribe and join us. It genuinely means the world to this channel. And if this video blows your mind by the end, and I think it will, drop a comment telling me, which moon do you think we've underestimated the most? I read every single one. Okay, let's go back to Saturn. To understand why this discovery is so extraordinary, you need to understand the world Mimas was supposed to be. When NASA's Voyager 1 spacecraft first photographed Mimas in November 1980, scientists did a double take. Staring back at them was something that looked almost designed, a small, pale moon dominated by a single enormous crater so perfectly circular, so absurdly large relative to the moon itself, that the internet would later give it a nickname, borrowed from a galaxy far, far away: the Death Star. The Herschel crater spans nearly 1/3 of Mimas's entire surface, 130 kilometers wide on a moon only 400 kilometers across. Whatever hit Mimas hit it so hard that scientists still marveled the moon survived at all. The impact would have sent shockwaves through the entire body. Cracks should have opened, the interior should have fractured. Instead, Mimas just sat there, frozen, silent, holding itself together like nothing had happened. And over the next 4 decades, every telescope, every spacecraft, every instrument that looked at Mimas confirmed the same story. This was a cold, inert, completely frozen moon. No heat escaping from the interior, no tectonic activity, no cracks where liquid might be pushing upward. Nothing but a battered ice ball orbiting Saturn every 22 hours. Compare that to Enceladus, Saturn's other small moon, orbiting just beyond Mimas. Enceladus shoots enormous geysers of water vapor hundreds of kilometers into space from cracks near its south pole. You can see it from a telescope. It is spectacularly, unmistakably alive. Or Europa, Jupiter's icy moon, where the entire surface is covered in crisscrossing fracture lines, the unmistakable signature of liquid water flexing and cracking the ice from below. These ocean worlds advertise themselves. They leave clues. They make noise. Mimas made none, which is why for 40 years nobody looked twice at it. That was the first mistake. In the years after NASA's Cassini spacecraft ended its 13-year mission, deliberately plunging into Saturn's atmosphere in 2017, researchers began the slow, painstaking work of analyzing everything it had recorded. Cassini was extraordinary. It didn't just take photographs, it tracked positions, measured gravitational fields, recorded orbital motion with a precision that would only reveal its secrets years later, when scientists had enough data points to compare. And buried in that data was something strange about Mimas. As Mimas travels around Saturn, it doesn't move in a perfect circle. It wobbles, slightly, almost imperceptibly. Astronomers call this libration, a gentle rocking motion caused by the gravitational relationship between a moon and its host planet. Every moon has it. But Mimas's wobble was wrong. Dr. Valery Laney of the Paris Observatory and his international team had been building a precise orbital model of Mimas for years. The model was supposed to confirm what everyone assumed, that Mimas was a uniform, solid block of ice and rock. A frozen, homogeneous world with nothing interesting happening inside. Instead, the data kept pointing to something else entirely. The way Mimas's orbit shifted, specifically how its point of closest approach to Saturn drifted over time, could not be explained by a solid interior. The numbers only worked if there was something liquid inside, something vast, fluid, and global, sloshing beneath the surface in response to Saturn's gravitational pull. The researchers checked the math again, then again. Then they published in the journal Nature on February 7, 2024, confirming what the data had been whispering all along. Beneath an ice shell 20 to 30 kilometers thick, roughly the distance from the ground to the edge of Earth's atmosphere, there is a body of liquid water that makes up nearly half the mass of Mimas. Not a small pocket, not a slush layer, a global ocean. And then came the detail that stopped scientists in their tracks. This ocean is young. Not young in the way we casually use the word, young in cosmic terms. Based on how Mimas's orbital eccentricity has been changing, the research team calculated that this ocean formed somewhere between 5 and 25 million years ago, at the absolute most. For perspective, the dinosaurs went extinct 66 million years ago. This ocean didn't exist when Tyrannosaurus rex was alive. Saturn's small, battered, supposedly dead moon has been quietly growing an ocean in secret. An ocean that is, by the standards of the solar system, brand new. So how does a frozen moon, cold, old, and battered, secretly melt from the inside? The answer is tidal heating, and it is one of the most remarkable forces in the solar system. When a moon orbits a planet in a slightly elliptical path, not a perfect circle, it moves faster when it's closer to the planet and slower when it's farther away. Saturn's gravity pulls harder on the near side of Mimas than the far side. This difference creates a continuous, gentle squeezing and stretching of the moon's interior with every 22-hour orbit. Think of it this way. Take a stress ball and squeeze it rhythmically, over and over, millions of times. Eventually, that friction generates heat. Not much heat in any single squeeze, but across millions of years, across trillions of orbital cycles, that heat adds up. At some point in the geologically recent past, something perturbed Mimas's orbit, bumping it from a nearly circular path into a more elongated, eccentric ellipse. Scientists believe this may have happened through gravitational interactions with other moons in Saturn's complex system. That increase in orbital eccentricity meant more squeezing, more friction, more heat, and over the next 10 to 25 million years, that heat quietly began to melt the bottom of Mimas's ice shell from the inside out. Now here's the part that makes Herschel crater so important. When that enormous impact struck Mimas, roughly 4 billion years ago, it left a crater with a very specific shape. A distinctive central peak, undisturbed walls, the kind of morphology you only get when the ice shell is thick and cold and solid all the way down. Scientists ran simulations. To produce the exact Herschel crater shape we observe today, The ice shell at the time of impact must have been at least 55 kilometers thick. Today, that same ice shell is only 20 to 30 kilometers thick. That tells us the story directly. Mimas has been melting from within for millions of years. The Herschel crater, the feature that made Mimas famous, the scar that made it look like a weapon of fictional mass destruction, is also the most precise thermometer we have for understanding exactly when this ocean began to form. The crater that almost destroyed the moon became the key to understanding what was growing inside it. For decades, the search for life beyond Earth followed a simple map. Look for liquid water. Liquid water requires warmth. Warmth requires proximity to a star or dramatic, obvious geological activity. Geysers, volcanoes, fractures cracking the surface open like a wound. That map led us to Europa, to Enceladus, to Titan, places that announce themselves, places where the signs are hard to miss. Mimas rewrites that map entirely. If Mimas, the most obviously dead-looking moon in the solar system, has been quietly growing an ocean for millions of years without a single surface sign, then we have to ask an uncomfortable question. How many other worlds have we dismissed? How many moons across how many planets are right now sitting silently in the dark, harboring liquid water beneath the surface? Unmarked, undetected. Not even on our search list? Scientists are already looking harder at the moons of Uranus. The Uranian system is in many ways similar to Saturn's, an array of mid-sized icy moons that have long been assumed to be frozen solid. If the Mimas model applies there, any of them could be ocean worlds we've never suspected. And then there is the question of life itself. Mimas's ocean is young. Almost certainly too young for complex life to have developed. But remember, life on Earth appeared remarkably quickly after liquid water became available. The early ocean is where chemistry first learned to replicate itself, where the first primitive cells emerged from the chaos of molecules. Mimas is showing us what that moment looks like, right now, in real time. Not millions of years ago, preserved in ancient rock, but actively happening in an ocean that is still forming, still stabilizing, still setting the conditions that life requires. It is quite literally a window into the beginning. But here is the thing nobody tells you. The ocean inside Mimas is temporary. The same force that melted the ice, the tidal heating generated by Mimas's eccentric orbit, is also slowly circularizing that orbit again. As Saturn's gravity extracts energy from Mimas's elliptical path, the orbit is becoming rounder, less eccentric, less squeeze, less heat. And when the orbit becomes circular, when the tidal flexing stops, the heat generation ceases, and the ocean, with nothing to keep it liquid, will slowly, inevitably begin to refreeze. Mimas is not a permanent ocean world. It is a window, a brief, geologically fleeting episode in the history of a small moon. A few tens of millions of years in which liquid water exists, in which the chemistry of life becomes possible, before the ice closes back in and the window shuts. We are watching that window right now. By cosmic coincidence, at this exact moment in the 4.5 billion year history of the solar system, humanity exists and has built spacecraft sensitive enough to detect a wobble in a moon's orbit, and has scientists patient enough to spend years analyzing that data. We arrived at precisely the right moment to notice. A few million years earlier, the ocean wasn't there. A few million years later, it may be gone. And we caught it. There is a kind of humility that only the universe can teach. For 40 years, we looked at Mimas and saw exactly what we expected to see, a battered, frozen, unremarkable rock. We were so certain of what it was that we made it a benchmark for lifelessness. We named the rule after it. And beneath that surface, invisible, patient, entirely indifferent to our certainty, an ocean was growing. The lesson of Mimas is not just about one moon, it is about the nature of discovery itself. The universe does not announce its secrets. It hides them inside the places we've already dismissed, beneath the craters of dead worlds, in the wobble of an orbit no one thought to look at twice. Every assumption we make narrows the search. Every certainty closes a door. Cassini gave us everything it had, and then it burned up in Saturn's atmosphere, vaporized, absorbed into the planet it had spent 13 years studying. But before it disappeared, it left us something extraordinary. Not just images, not just data. It left us a question. If Mimas has an ocean, how many other dead worlds are alive? If this video made you see the solar system differently, I'd genuinely love to know. Drop a comment below. Tell me which world you think we've underestimated. Tell me what discovery you want us to cover next. Your comments are what keep this channel going, and I read every single one. And if you're not subscribed yet, now is a great time. Every week we tell the stories of the universe's most shocking, most beautiful, and most overlooked discoveries. Hit that subscribe button and ring the bell so you never miss one. It takes 2 seconds and it means everything to a channel like this. If you know someone who loves space, share this video with them. Not everyone knows Mimas exists. Change that. We'll see you in the dark.